Welcome back. In this video, we're going to continue with our objective 2.1, which is to understand the derivative as a slope and evaluate its using its definition, tables, and graphs. Particularly from this lesson, you will be able to evaluate derivatives from tables and graphs, write equations of tangent and normal lines from tables and graphs. And this is a continuation of the notes and discussion we had the day before school ended. So you have, I've cut and pasted some of the worksheet or all of the worksheet that I gave you. It's not really a worksheet. This is eventually going to go paste it in your notes. And we're going to go through it to make sure that you're really prepared to answer questions from tables and graphs. We start the first question given a table, assuming the f of x is continuous. And they gave us some information. Here's x, here's f of x, which of course is y values, and here is the derivative values. What's important about this is we are not given the function, but we're given these values to work with, which means for the derivative, we don't have to do any work. We just know these are the slopes of the tangent lines at the given x coordinates. So the first question says, write the equation of the tangent line, so it's going to be tangent line, to f of x at x equals -4. Okay, so I'm working with x is -4. So I already have all the information I need to get started. If you recall, we're using the format y minus y1 equals m being your slope of tangent line or derivative, times x minus x1. And for this, we are going to be needing the slope of a tangent line, which is a derivative, and any point on the line. We know that we want this line when x is 4, and when x is 4, y is going to be 0.75. So I know the point is going to be -4, 0.75, and I also need a slope. Remember that the slope is the derivative. Well, the derivative here is -3. So I'm ready to go. I can use my point slope form. Y minus 0.75 will equal -3. And that will be times x minus -4, which of course becomes positive. I do not have to solve for y, so that's it. The second problem asks for the equation of the normal line. Okay, the equation of the normal line, but not at -4. This time it wants it at -1. So I'm going to go over to -1 and use the information I have for -1. Remember, the slope of the tangent line is 1.5. So the point is going to be -1, -1.5. The slope is 1.5 of the tangent. So for us, it's going to be the reciprocal, the opposite reciprocal. I'm a little uncomfortable with using decimals and doing reciprocals, so I'm just going to change 1.5 to 3/2. That's the same as 1.5. And I'm going to take the opposite reciprocal, which would give us -2/3. And that's going to be the slope of this normal line. So I'll do my setup. It'll be y minus a -1.5. And the slope is the opposite reciprocal, -2/3. And then I'm going to multiply that by x minus a -1. So these become positive. I do not have to solve for y, so I am done. Alright, for number 3, it wants me to write the equation of the tangent line again, but this time at -2. See if I can switch colors there. -2 is all this information. I notice right away my slope is 0. If my slope is 0, that means I'm working with a horizontal line, and that means horizontal lines always have the equation y equals a number. Specifically, it's not going to be -2 because that's x. It's actually the y value at that point. So y equals -2.25. And I know it equals the y value because it is a horizontal line. Lastly, I'm being asked to write the equation of a normal line at -2. Well, if the tangent line is horizontal, the normal line will be a vertical line. Vertical lines have the equation x equals a number. So in this case, it will just be x equals -2. I did not need for 3 and 4 to use point slope form because those are special lines. All right, so let's scroll down and look at the next question. All right, so for the next question, it says again to assume f of x is continuous, and here's my table of values. It says write the equation of a secant line on f of x that passes through 1 and 3. Well, a secant line means it touches in 2 points. First at x equals 1, and next at x equals 3. Well, I don't need a derivative here. I actually need to find the slope. If I have the point 1, 10, and the point 3, 54, I'm going to run slope formula to compute the slope, and then I will use any of the 2 points to write my equation. So I have my work here. I use the slope formula, the traditional formula, to find my slope, and then I can either use the point 110 or 354. Since I'm not solving for y, they look a little bit different, but if I did solve for y, they should look exactly the same, and either one would work. You do not need both, you just need one. The next question asks you to approximate f prime of 2. If you notice, f prime was not given. So we need to find the derivative at this point. Now, I can't really say 28 minus 0 over 2 minus 0 because that would be the average rate of change over the interval 0 to 2. And I need the instantaneous. I also cannot pick a number really close to 2 because the only numbers I have are what's given. And so in a case like this, what you would do is pick the numbers that are closest to 2 and a closest number. Now, 2 is 0.5 units away from 1.5, but it's also 0.5 units away from 2.5. So it actually does not matter in this case which 2 you pick. Now, you might get different answers depending on what you pick, but both of them would be the best approximation to that derivative. So I'll just take the first 2 and run the slope of those. So I went ahead and ran it with 1.5 and 2, and I came out with 20. 10 divided by a half is the same as 10 times 2. That's a decimal there, so I get 20. Question number 7 is going to be very similar. It's at 0.5. If you look at 0.5 here, we are going to pick a point that's close to 0.5. And since 0.5 is the same distance from 1 than it is from 0, either of the 2 points would give you the best approximation. Okay, so let's scroll down and let's look at things graphically now. So in this particular example, you are being told that f is continuous, and you're being asked f of 6. f of 6 is just a y value, so we'll go to the graph. It's really important that you identify that this is a graph of f. And so if you go to 6, the y value at 6 is going to be -1. Oops. It's going to be -1. And let's see if I can put that on there. Here it is. So it's going to be -1. Now the derivative at that point is going to be the slope of the tangent line. Because this happens to be a line, the slope of that line is just going to be the slope of the tangent line, is just going to be the slope of this line. Now you don't actually need this point to compute the slope. It doesn't matter what 2 points on this line you pick. The slope will always be the same, but you can tell here that it's going to be down 1, run 1, down 1, run 1. Let's see if I can show you that. So of course the slope at any point between 5 and 7 is going to be -1. Now, the equation of the normal line when x is 1. Well, I know this says 1, and we could actually do that equation, but I'm going to go ahead and change this to 6, because that's the information that we're working with here. Since we have the y value and now the slope, you would simply write the equation. Now, that's going to be the same equation as the equation of the line you see, because the tangent line and a line are the same. I do have to make one change here. Since it doesn't say tangent, it says normal, I actually have to change the slope. It has to be the opposite reciprocal. So the opposite reciprocal of -1 is just +1. Okay, so let's go with 3. And we're going to change this to 3 as well. If you go to 3, the y value at 3 is 2. The slope of the tangent line there is going to be 0. And then as for the normal line, well, the normal line is going to be perpendicular, so that's vertical line. So that would be x equal to 3. Okay, let's scroll down and take a look at the next one. Okay, in this example, I didn't label this graph, so it's important that you label it f of x. That makes a difference what it is, and you'll see in the next example it's the derivative. This is just f of x. So if it wants f of 2 is 4. Now it wants the derivative at 2. Well, at 2, if we drew a tangent line there, you can see it's horizontal. So its slope, of course, is going to be 0. Now it wants the equation of the line tangent when x is 1. I'm going to change this 1 to 2. It's just a typo. If I want the equation of the tangent line at 2, this is a horizontal line. So all it's going to be is y equals whatever the y value is at that point, which is 4. So there's another place where the slope of the tangent line is 0, and that happens here at 5. So if I were asked the same question about 5, what's the equation of the tangent line, I would have said y equals -2, and the derivative at 5 would have been 0. Now it's going to ask us to do some comparison. It wants us to compare f prime of 1 with f prime of 3. It doesn't ask us to give the actual values, just to use less than, greater than, or equal to. If we go over to 1, f of 1 is f prime of 1. I'm not really sure what the slope is, but I do know that if I draw a tangent line, it has a positive value. And if I go to 3, again, I'm not sure what the slope is, but it has a negative value. Positive, negative, so I know this is a positive, this is a negative. Positive is bigger than negative, and I can fill in the blank that way. The next example is f of 3. f of 3 is the actual y value. Again, it looks like maybe 2 or a little bit bigger than 2, but either way, it's a positive value. But now it's asking me to compare it with the slope at that point. Well, the value versus the slope. The slope is negative, the value is positive. Remember, this is just a y value, and this is a slope. So again, positive beats negative. So I'm going to ask you to stop the video and go ahead and finish these up, and then we'll compare with me. So I've filled out my signs here and my inequality symbols. So if you'll take a moment and go ahead and compare your work with mine, and then we'll scroll down and take a look at the very last example. Okay, so in this example, notice that the graph that is given is that of the first derivative. This is f prime of x. What that means is that we have never seen the original function. All we know is that these are the y values for the derivative. That means every point on this graph represents what the slope of a tangent line was on the original. So it says if f of 1 equals -3, remember you've never seen the original, so you just have to trust that this is true, that it contains the point 1, -3. Write the equation of the tangent line to f of x at x equals 1. Remember, this is not the original, this is the derivative. At x equals 1, the y value, which is the derivative, is 2. So what that means is that our slope is 2. And the point x comma y comes from the original, and that's the information they gave us. So we simply fill in the blanks. That's -1. It becomes positive. How about at 1, the normal line? Well, it's going to be the same exact information, but this time we're going to take 2 and we're going to do the opposite reciprocal over there. So let's take a look at the one on the right. In example 5, again, this is the first derivative. It says that f of 3 equals 4, so that tells me the point 3, 4. And asks me to write the tangent line when x is 3. Well, when x is 3, I'm not looking at the slope anymore, I'm just looking at the y values. It says that the derivative is going to be equal to 1. So that means that the slope is 1. So y minus 4 equals 1 times x minus 3. Now this 13 says f of 6 equals -5. That's my point. And it says to write the equation of the tangent and normal lines when x is 6. Well, at 6, the y value is 3. So m is 3. I'm just going to do tangent because normal would be the same with the opposite reciprocal slope. So what's very important to remember here is if the graph is labeled that it's the derivative, the y values are your slopes. And if it's original, then you have to actually look at the slope to get the derivative.